Alright, so let's see how we can find a harmonic conjugate function of this given u. So we can see that this function u satisfies the Laplace's equation, that is nabla squared u is equal to 0. And if this function satisfies this Laplace's equation, then we know that this must be an analytic function, and if it is an analytic function, then it must satisfy the CR equations. Okay, so let's write this. Let's find the u sub x of this function, that is equal to 2x, and u sub y is equal to minus 2y minus 1. And because this satisfies the Laplace, this satisfies this CR equation, so this ux will be equal to v sub y, and this uy is will be equal to minus v sub x. So let's rewrite this equation. V sub x is equal to 2y plus 1, and now let's differentiate. Now let's integrate this with respect to x. Then we have v equals 2xy plus, instead of writing x, let me write this one as a function of x, that is h of x. And there is no need to write the constant of integration because that is included in this function only. So what we can do is, let me again differentiate this with respect to x, that is equal to 2y plus dh divided by dx. And now let's equate this with this equation, that is equal to 2y plus 1. Now if we can see this 2y get cancelled out on both sides, now I'm left with dh by dx and 1. And we write it here, dh divided by dx, dh over dx is equal to 1. So from here we can find h of x will be equal to x plus c. So let me put it in this equation, that is v is equal to 2xy plus x plus c. So this is our harmonic conjugate function v, a general one, quite general, because we have a constant integration here. Now if we want to complete function f of z, then how we can do that, let's see in the next page. Let's see, we can write f of z is equal to u plus iv, because we know that generally we can write this f of z as a function of u plus I times a function of v. Let me write that u as, we have this u x squared minus y squared minus y plus I times v. We just found v, that is equal to 2xy plus it was y, I think, no, it was x plus c. Okay, so we need to regroup them and find the final answer in terms of z. X squared minus y squared plus I times 2xy, I can rewrite this as f of z is equal to x plus I times y quantity squared, and this minus y I can write it as plus I times I y, and I can group this with I times x here, that is I times I y plus I times x here. I don't need to write this I here, let me just write x plus c. So, and z is equal to x plus iy, so let me rewrite this as f of z, that is equal to z squared plus I times, now this is z plus z c. That is the final answer.